What's going on, Badgers? This is Wasabi. Welcome to the Badger Podcast. I'm talking today with Alex, the Entreprenerd, and Mitch. Alex is a lead dev on the Solidity team, and Mitch is lead dev on the, Web 2.0 front end rewards kind of stuff. What's going on, guys?
Thank you for having us, Wasabi.
How's it going, Wasabi?
So today we are talking about steps that Badger has taken and is continuing to take to secure all stages of its service, from the smart contracts to the front end to interactions with users and institutions, in the wake of the exploit that happened in December. So for kind of like the canonical explanation of what happened in the exploit, that's been reviewed and approved from all over the place from our security consultants. I'm going to send everyone to the technical postmortem. That's badger.com/technical post mortem. But just, I don't know, Mitch, do you want to just give us kind of like a quick two-sentence summary of what happened, that will kind of enable us to frame some of the steps that we're taking to make sure that all the tech is hardened going forward?
Yeah, so there was a potential exploit in the way we signed up for a service that we use to route DNS. And that exploit was taken advantage of and injected malicious scripts into the content that was served to users. So, like the website that people see. Um, Over a period of time, it kind of maliciously farmed these approvals to a external address, and that external address eventually ended up just withdrawing from those accounts that it had approvals for.
All right, and so we have been, when this happened, we did a top to bottom review of all the different stages of the technology, from the smart contracts to educating users about making sure they're not approving malicious code, to the front end. And today we're just going to focus more on things that we have created that other developers can use, and kind of like best practices and advice that we want to put this out here to share with other Web3 members of the community. So let's, I don't know, Mitch, why don't we start off with just kind of like the basic Web 2 changes that were made. And I don't know, imagine you're at a ETH conference and you run into someone who is Dapp developer, and you're talking about what happened. So like, what are some of the kind of like tips that maybe people shouldn't necessarily think of or wouldn't necessarily think of, but what are the kind of like the basic things that you would tell them to be checking for?
Um, well, the first thing is when you first create an account, regardless of if you think that it's secured or not, you should look into anything that potentially has admin access to that account. So, for example, any API keys or anything like that. Even if you think that they've never been touched, you should still go in and just rotate them. It would be just a best practice to make sure that that's all fresh and nobody has access to it. Um, in terms of security for larger teams and things like distributed teams where you don't really know people, you need to be very careful about accesses that you grant, any permissions that you give in terms of like modifications, and how they sign up for those accounts and secure their passwords. So the majority of these large companies allow you to require multi-factor authentication, which helps with security of accounts. So that can be done in a number of different ways. An SMS would just be like a text message sent to a phone number that you have. A TOML MFA, which is like your Google Authenticator app or something like that on your phone. And then like a hardware account or hardware key, which would be like if you had a YubiKey, or actually you can do it via Ledger. Ledger has a authentication app. So like those are kind of ranked in order of security. SMS is like the least secure, because you could very easily spoof a SIM card and get SIM swapped, and somebody could get access to things. The second is the TOML, which is a little less secure. and then finally the hardware is the most secure. So what we did is we definitely encouraged, or we enforced MFA on everyone's account that interacts with anything that's secure now. Um, and for any admin accounts, we strongly suggested that they use hardware and enforced it wherever possible.
So I've been on the admin of several of these things, not in Badger, but in other places, and I know there's ways to enforce MFA. But are there ways that you can enforce like YubiKey MFA or like the top tier of that, or is it kind of anything that the user wants?
Yeah, it depends on the application. There are some, like I believe that AWS allows you to say like you can only use or you can't use SMS. I think that's pretty much the level of where you can say that it needs to be. Toml is pretty secure, but obviously the YubiKey is and Ledger are the most secure.
Got it. Okay, so going back to what you said earlier, that there was this script that was injected into the site, and I think here we kind of want to get into some of the proactive monitoring stuff that has been set up, because I think
Mm-hmm.
that's probably some of the most interesting tech that's come out of this, and something that we want to be able to share with other members of the community. So, what is Redwall?
Okay, good question. So Redwall is an application that was developed by one of our developers, designed to be an open source tool that we're going to be giving people access to, or making just public, um, where it will monitor the blockchain and see if there are any malicious approvals or potentially malicious approvals that are going to your contracts. So those could be, uh, some like external address, like an externally owned address, or a non-smart contract address. Um, or it could be anything that you really define. So you could say like, we only expect approvals to be given for this contract to this list of addresses. If anything else, notify us. So these will be tools where we can do that, and then it will also have a front end where you can have users go to and monitor the approvals for the smart contracts that you want to monitor.
Can I ask how that works? Because I'm thinking like, okay, say a user, say my wallet is interacting with Badger, right? Like you could see who, what wallets are interacting with known Badger contracts. But how would you be able to see an alert if my wallet interacts with some random hacker address? Like how would the app know that this is a hacker address before there's a hack?
So the way that approvals work is you grant approvals on the contract to an address. So it's actually an interaction with the contract, not like a hacker's address. So, for example, you would send an approve transaction with the hacker's address rather than, the Badger set vault address for to spend your IBBTC curve LP for like infinity money, essentially. So what we would be able to do is we could see that the curve LP had this approval given to a contract that wasn't expected, and alert people about that.
I see. So you're setting the alerts on the Badger token contracts rather than
Well,
the,
it's
the where
technically
you're giving the
technically the
user.
want of the Badger token contract. Yeah.
Interesting. Okay, that makes a lot of sense. So is this something that is up and running now? Is it something that other devs can get off our GitHub and start using, or what stage is this at right now?
Yeah, it's up and running right now. We're testing it and making sure that it's like ready for public consumption. We have it running where it's probably alerting more so than it needs to be, but it's better to be safe than sorry. But once we have that pared down and get that all set up, then we can go ahead and make that more public.
Awesome. And after in some of our discussions, I know there was also talk about creating a script that looks at a hash of the actual code of the front end site that it's going to users, and can see if there's any change to that that's unexpected. Like, is that something that this Redwall supersedes the need for that, or is that something that could be working in concert with Redwall?
No, it definitely works in concert. So the more monitoring tools, the better, right? But the idea of this script monitoring tool is that it will build a version of the website from the code that's available on GitHub, and then compare that to the version of the website that's served from app.badger.com for say. So what it does is it'll compare that and make sure that those are identical. And if there are any differences, it'll send alerts and log those alerts. So this way we can say, okay, there's an additional script tag in app.badger.com versus what was built locally. You should go investigate it immediately and see if that's an expected thing that was injected on purpose or if it was malicious.
Okay, and does that have a catchy name, or is that something else?
No, website scraper is all we call it. We haven't come up with a catchy name for that one.
All right, I'll work on that. We
Yeah.
need catchy names are good. Cool. What else? What other front end stuff? So if you're a developer and you're listening to this, we would encourage you. Like these are both available on the Badger GitHub for use right now, right? So anyone can go grab these and set them up on their Dapps.
Redwall, I believe, is open source, but I don't think the scraper is. That still needs a little bit of work. It's running, but there could be some improvements that we want to do. But yes, those will be open sourced and available for consumption in the next few weeks, I would say. The less interesting stuff is kind of just like configuration things that we've done. So we have like 3 layers currently in our current architecture, which we're going to be just moving all to AWS. But currently we use AWS. Then we have Netlify, which handles our continuous integration and deployment, and then Cloudflare, which has some monitoring, handles our DNS records, and handles anything like prevention of DDoS and things like that, like a denial of service attacks. Um, so at the Netlify level, we have started to monitor the audit logs more deeply. We have set sign commit sign commit requirements for GitHub, which is where it pulls data from. So people can't have any like spoofed GitHub credentials that could get potentially bad code in. And then just deployment notifications, so we're aware if there are any modifications to the Netlify that weren't expected. Um, for Cloudflare, we set up notifications for everything that happens there possible. We have script monitoring that's built in, Page Shield that lets us know if there are any like DNS leaks or anything like that, and then just a number of like just increased firewall rules that will help prevent any potential security leaks. So this is just like getting us to like in a more institutional grade security versus what we had before.
Got it. And while I have you both on, I want to ask you about this because basically, like in crypto, all of us are on Discord at all hours of the day, and it's just become like a part-time job to monitor Discord. And I don't know about you, but I have my DMs open because, like, I don't know, some random person that needs to talk to me might DM me. But it's become a part-time job just to like report the spam and block people, and it's really annoying. And I've been seeing more and more reports of other projects having their Discord servers getting hacked, and like really serious exploits that allow hackers to take over an entire Discord server for like a legitimate project. What do you personally do with your own Discords, and do you have any kind of tips for like Discord hygiene for other projects to keep safe on there?
Yeah, so I admin a number of Discords, so it or moderate, I guess. So like the things that I've seen is like in other Discords, I've seen webhook URLs, which is like how bots push information to the Discord. Those get hacked, so it looks like official information coming from the Discord, um, but it's really like linking you to some bait contract that will end up screwing you over. So there's a number of ways you can help secure your Discord if you are somebody who handles those things. Number one is Discord does have MFA. It's not really widely known or used to my knowledge, but I enabled MFA on my account as well. And then anytime you ever have to send those webhook like URLs to anyone, if you're maybe sharing it because somebody else is running a bot, you should always use an end-to-end encrypted communication service. So like something like Signal is an application where you can communicate uh, with end-to-end encryption, and I would highly suggest anybody use that for any communication of any sensitive information.
And I'm curious, what do you do personally? Do you have your DMs turned off, or is it
My
something
DMs
that?
are open, but I have myself as always displayed as logged off, so bots don't bother me. But yeah, I'm my DMs are always open.
I saw a report of a really kind of sophisticated, like social engineering type Discord hack where it was like someone was they'll kick you off of a Discord, and then that you're in, and then say that you're an exploiter was mimicking you or something like that, and then they get you to share your screen and do a view page source of um, a Discord, I guess through the web. I'm not sure if you can do view source of the actual app, but then when you do that, then that exposes like an API key or some kind of like private credential that then they use to take over your own
Huh.
account. Have you ever heard of something like that happening?
I haven't heard of it, but in general, if someone is reaching out to you and asking you to share your screen, you should just never do it. Yeah, unless you're really confident that that person is somebody that you know and trust, or it's like an official website and you verified the URL and you're 100% sure that it is that site, then maybe at that point they may have you share your screen. But in general, I would be extremely leery to ever share my screen with. But that's pretty sophisticated, and something I have never.
Yeah, I want to speak to the interpretation of that, and I have to absolutely agree with Mitch in that you should never share your screen. Uh, Honestly, you may never share your screen for any reason. And more generally, you should assume that whatever you share no longer has any privacy. That goes, for example, when you do tutorials, you may be showing your bookmarks, you may be showing your email, that kind of stuff. Anytime you share your screen, you may be sharing more information than you realize. So you should be extremely cautious about that. And in general, when it comes to private messages, you should just show a level of skepticism that is pretty high, because the cost of sending you a message is basically zero. But the risk that you may take in clicking a random link or in being phished or getting your identity stolen can actually be enormous. You can lose hours, if not months of your time in having to fix that kind of problem. That said, to speak to your specific attack of stealing a session token, that would really depend on the technical implementation of an app such as Discord. But most apps do use what are called either session cookies, or some apps even store the cookie for identity in the local storage, which is actually a fairly high vulnerability, but it's easy for the developers to do. And so I can imagine a time in which any application would actually expose these identity credentials through a unsafe API, which means that if you just get the token, you basically become the other person. And so again, don't open the console in front of other people, and don't show them any data that may either give sensitive information away. So I highly recommend extreme levels of skepticism when it comes to that.
Got it. Is there anything else on the front end Web 2 stuff before we move on?
No, just some things coming in the future is that we're going to talk on it a little bit later, but we are looking to decentralize the front end. So we're going to have IPFS deployments of the website, and I have them linked either on badger.com or app.badger.com. We're also going to have like a Fleek deployment, which is like a persistent link that will link you to the most recent IPFS. Um, And then we'll also be open sourcing the front end where you would be able to just download the code and run it yourself if you are technically inclined.
Back up a little bit and kind of give an intro to IPFS and why that's so important for not just Badger, but other Web3 projects and kind of moving towards full decentralization.
Yeah, so IPFS is essentially just like at a high level. Alex can probably talk to it a little bit more than I can in terms of how it's actually run, but it's a decentralized file storage system where you can pin static content to IPFS and serve that from anywhere. And it can't be like, it doesn't need to be hosted by like a DNS or anything like that. There's also a cool thing where you can route to IPFS destinations via an ENS. So if we had like a subdomain of app.badgerdao.eth, which is our ENS name, it could route you to the IPFS. So things like that are pretty cool, where it just makes it to so it's like completely Web3. It's not like a domain that's hosted by or a registrar like AWS or something like that. It's just on IPFS, and that's enabled by websites with just static content that are kind of like just rendering information from the blockchain.
And is IPFS, when you say decentralized file storage, is that its own blockchain that's being stored, the files are being stored on, or how does that work fundamentally?
Alex is right.
Yeah, ultimately, IPFS is a lot closer to a torrent where everybody shares copies of the data. Somebody may have the full copy, somebody may just have a shard of it, a piece of it. Every piece of content can be hashed similarly to the idea that we use to verify the integrity of the website. You can hash some content into bytes, and from those bytes, you can get a unique identifier, which IPFS, I believe, can be recognized because they have, I think, either a Q or a C based on the hashing algorithm. But basically, you can determine that it's an IPFS hash, and any content will correspond to that specific hash. There could be a collision, but if you do the math, the number of possible hashes is more than the atoms on the universe, so the likelihood of collision is very low. And that basically means that once you build your own front end, let's say the Badger website, we can just get this hash from IPFS, and now we can share that hash, and then completely trustlessly, other people can get that website and verify its integrity by themselves. So, given the original source code, the IPFS hash, and then the IPFS system, people can utilize the website without relying on a hosting service or neither having to rely on the entire website stack, the internet stack. Obviously, this presents other challenges, which is the fact that we would have to give up the usage of APIs, which I'd love to kind of get your thoughts on, Mitch. But from my perspective, this is actually one of the biggest opportunities in web development. It's the ability to write view contracts, so smart contracts on chain that effectively act as APIs. And I believe this can be achieved, and obviously it's not easy, but it can be achieved. And it may even improve performance because the Ethereum nodes are actually very sophisticated machines, and they allow to do thousands, if not hundreds of thousands of computations within one call, which would allow to present the majority of the website data in literally one smart contract call.
Yeah, that's an interesting thing, and something we should definitely explore. The API that we currently use is used for a number of reasons. It caches data, so people don't have to be querying the blockchain quite as often, which helps with just like costs in terms of RPC calls. In the decentralized version of this, everybody would have to provide their own RPC. So like that's not that big of a deal if you're only one person and you're only making a few calls. But it could get very expensive if you're a website. So like our RPC costs are pretty high because we do have a number of users that connect via like Wallet Connect, which we have to provide an RPC for. So utilizing the API allows us to like cache that data that only updates every, say, 13 seconds, or the Ethereum blockchain, however long a block takes, and serve that less frequently, but from like a centralized database, which presents its own issues, because if that is compromised, it could be giving incorrect data. But it's really only read data, so it's not really anything that is extremely sensitive.
So when you say expensive, do you mean that you're actually paying gas to query the blockchain to just get kind of like usage data or data that would be displaying in the app just in a normal way when you're connecting it within now?
No. So we have RPC providers that essentially run nodes for us. So, like Infura is an example of that. And they have like a rate that they charge you per call or whatever. So, like, say you have a million calls a day or something like that. But if you have 10,000 users that are querying every 13 seconds, that those add up very quickly. You know, um, so when we go over certain things, you get charged an additional rate. So it's really like data egress costs,
I have to
essentially.
agree with Mitch that the challenge in building a product versus building just a piece of tech is it gets very subtle, and so the centralized RPC is kind of one of those trade-offs in centralization versus decentralization. Because ultimately, having a person be forced to unlock their wallet provider and having to provide their own RPC is actually kind of a big ask. Uh, if we had a very simple security discussion, I would, as a general hygiene rule, I would recommend to never unlock your MetaMask. That doesn't sound that sounds very intuitive to most people, and yet a fully decentralized front end would require that you unlock your MetaMask to be able to even view the data. An example being Rari Capital versus Saffron.finance. I'm not sure if any of you remember the SPICE, SFI, but their website requires you to unlock MetaMask, while Rari uses a RPC. And obviously, if you look at what happened in a year from when they both launched, Rari is massively more used than Saffron, just because the kind of that decision of centralizing RPC.
Let me ask you this: when you say a user providing their own RPC, how much of a technical lift is that for like an average user? Is that something that would be beyond the capabilities of a everyday ape like myself?
Um, so when you connect to like a website or like a DApp with MetaMask, MetaMask has a RPC that it provides just internally. So, like, if you looked at your network configurations, you could actually see the RPC that's set up for your addresses. Or, like, say you add in a new network, if you added in, say, Phantom, for example, when you add that network in, you provide an RPC. That's a centralized RPC. And if you want to use that, that's fine. If you wanted to run your own, that's a lot more technical. You would need to run a web server, which could handle RPC calls from a node that you run, maintain. So there's like varying levels, I guess, to the answer.
Yeah, well, that's solved by using IPNS. And I think we actually went through the flow with the other front-end developer who's not here, Jintal. But basically, Flick will allow you to set the IPNS content hash on your ENS. So you're going to go on your ENS and set the URL to be a IPNS, which is the IPFS name service. And then the IPNS is actually dynamic enough to make it so that it will point to a different IPFS content hash when you update the site. So that's how you can solve for dynamic routing. However, in terms of verifying the integrity, yes, every single time you change the website, the IPFS hash changes, which means that the end user, if they want to be very thorough with their checks, they would actually have to compare a new IPFS hash every single time they get the website.
Mitch, do you know of any other DeFi apps that are IPFS or that are more fully decentralized? Are there any kind of examples that a user might be interacting with already that are at this other framework?
I've seen them. I can't think of off the top of my head, but it's tough because so there's this like Netlify alternative called Fleek, which essentially does the same thing as Netlify, but it publishes to IPFS rather than hosts it locally. So you'll get this like fleek.co um, routing URL that you can use to access IPFS, and it'll keep that updated. So that they're like publishing to IPFS means that every time you publish a new version of your site, you have to give a new link to the site. So using Fleek kind of abstracts that.
Yeah, so I'd say most decentralized protocols have doubled in the idea. I believe one of the first protocols that have done it and committed fully will be Augur, the prediction markets decentralized website on which used to be on Ethereum. Now they moved to Polygon. I think they were the first. I would say to their detriment. My experience has been in terms of a business, in terms of competitive advantage, that other competitors that chose not to decentralize have had much more success because of it, because of the complexities of decentralization. However, if you go on Augur right now, after you visit the website, you can click a view app or use app or something like that, and it will send you an IPFS. The second notable example, and I think what happened is interesting, but the second example would be compound.finance. They decentralized the website, and I've been speaking to their head of developer relations about what they did. And funny enough, since they decentralized, which I think happened back in October, they actually backtracked now. And so if you go on the website now, you'll see that the compound.finance website sends you back to the centralized version of app.compound.finance. I'm assuming because certain users have voiced their problem in having to either provide the RPC, the fear of using this random gibberish URL that is really scary, and the slower loading, because decentralization does bring its own issues, and re-centralizing to solve that ends up not working. So I would say in general that the tools are there for people that do want to get that higher level of sophistication and that higher level of security. However, as an industry and currently, our playbook comes from Web 2. It comes from the Silicon Valley scene, where you got to make things fast, you got to cache, you got to use load balancers and that kind of stuff to provide the best user experience. And so in that playbook, decentralization is a trade-off. And as such, it does provide just a big challenge in actually providing a good user experience, because you can, but the amounts of hurdles you got to go through are ridiculous. I would say 10 times, if not 100 times more work to be able to handle a decentralized front end that performs as well as a centralized one.
That's really interesting. I mean, there was this article that a lot of people were talking about by Moxie, who said a lot of the same things, right? He built several different dApps, kind of like coming from Web 2 to be dabbling in Ethereum and launching kind of smaller projects, and said a lot of the same things about how basically there is this core decentralized network that it's running on, but in order to make things fast and pretty and easy user experience, you have to go to these centralizing Web 2 playbooks. And that is a real, I don't know if you think it's a challenge to be overcome. Or are we heading for a world like Compound where there's kind of like a easy mode and a hard but more decentralized mode? Go ahead. Do you think it's just a matter of more development to bring the decentralized tools up to the same level of easiness and speed and everything?
I wouldn't say we have to at all. I would say it's the default. I think it's a paradigm shift. Decentralization is a different way of looking at the pie. The pie is the same. It's a website. It's money. It's a protocol. It's all coordination. The pie is always the same. It's how we live our lives, and we find ways to live productively. But it's a different way of looking at the pie. And so decentralization is fundamentally trying to use trustlessness, the fact that I don't need to trust what you're telling me. I can verify it. And and I can verify it, and I can at the same time basically achieve my goals without that need for a third party trust. And so in order to do that more rapidly, you effectively have to either use tricks, or you have to basically be really good at what you're doing. Just like we spent 2 hours talking about one approval transaction in the previous podcast with Wasabi and me. That's all we did. We spent 2 hours talking about whether you should press a blue button or not because of some hexadecimal data. But when I do it in my day-to-day life, that takes me maybe 30 seconds. So ultimately, after you can use these different tools and you can use them productively, um, the trade-off becomes a lot smaller. It's just that it's very hard to get people to jump over the fence when we can use alternatives from a trusted playbook. So I almost see it as a leap of faith. I see it like us as the Web3 developers. We have to make the leap of faith first in using decentralized tools, and then trust that people will use them as well. And then the market will just decide. And currently, the market is kind of tilted, where when things go very well, let's say we're on the bull market, nobody gives nobody cares about decentralization, and yet when things go wrong, or when there's only people that are in it for the tech because we're in a bear market, decentralization becomes the most important thing. And so I think at the end of the day, decentralization is how we got here. Solving the Byzantine problem is literally why this industry exists. And so we should be leaning as much as we can, and slowly but surely we will be forced to fully decentralize. And so perhaps I think the solutions to these problems are already here. It's just the amount of work compared to using Infura or using a AWS or Next.js, that kind of stuff. It's just the amount of work is a lot bigger, and so it becomes like a quality problem for DAOs that really believe in it. So if you're not going to invest in decentralization, I think you're not going to get it. It's really a matter of committing to it.
Got it. Yeah, I mean, I definitely look forward to a future where there is a fully trustless and decentralized version of these apps that you can use. And I think once that's there and it's slightly easier to use, then it'll be not that big of a deal to bring people over that final couple gaps or teach them the few things that they need to get these benefits. But let's talk a little bit more about. So we've talked about the front end stuff. There are also just want to quickly note a few tools like Fireblocks that if you are a large institution interacting with Badger or other Dapps, that it makes sense to take a look at those. So I'm not sure which of you is best equipped to address this, but what are some of the things that if you're managing a fund or something and using Badger, like what are the tools that you should be using?
Yeah, you already mentioned Fireblocks, which is a great suggestion. They have a number of institutional grade security interactions. They have with DeFi platforms. They're experts in the field. And if it's something that if you're just a normal investor, or if you're somebody that's running a $100 million fund that's investing in DeFi, I would highly suggest you go through them rather than kind of doing your own thing. Um, there's also additional insurances that they offer and things like that. So it's just in general, it's the best place to go if you are somebody who has institutional grade level money. The other thing that we can talk about is that with our new interaction or our new development with set vaults 1.5 is we're going to be allowing smart contract integrations in or smart contract interactions with our vaults. This won't be available on Ethereum, in the near future, but we will be allowing things like Gnosis Safe and multi-sigs and Argent Wallet, which would be able to interact with our vaults, which currently cannot now. So if you're holding large amount of funds and you're interacting with our vaults, using a multi-sig when it's available is definitely a smart move as well.
Is it possible now to interact with Badger directly from Etherscan, or is that considered a smart contract that's interacting with it that's blocked?
No, you can interact with it through Etherscan. For certain things, you need information that comes from the API, like Merkle proofs that prove that the information that you're serving is correct, and allows for the smart contract to verify things. Um, if you're technically inclined, you could pull that in from the API and then manually enter it into Etherscan. But Etherscan is just like your wallet interacting with a smart contract directly. It's not like passing it through some other smart contract.
Got it. But it wouldn't be as simple as just like minting an NFT from the contract or something. You'd have to get into the API calls to get.
Well, depending on what you're doing. So, like, if you're claiming rewards, that's not simple. If you are just like depositing it or withdrawing from a vault, then yeah, that would be like as simple as well as the level of complexity of minting an NFT. Yeah.
Got it. Okay. So Alex, want to get back to you here to talk a little bit about some of the smart contract stuff. So the Badger smart contracts were not in play with this exploit that happened in December, but I think it's always good to, you know, point out that we are constantly doing audits and reviews of the smart contracts. So how I don't know, has the exploit changed anything in how you are kind of continuously reviewing the contracts, or do you have any updated thinking on that in the last couple months?
Yeah. Well, I would say personally that, and I believe this to every member of core at Badger, is that the exploit really put into question kind of why we're here, and it means like it basically it makes it so much more important to do things in a way that maintains our integrity and ensures that we are doing something we believe in. So I'd say the exploit didn't necessarily change our security measures, which I'll go through into detail. But it definitely just made me personally a little more cautious and just trying to really, in a way, understand the potential risks of the just working with this technology. In terms of our basic flow, our basic flow is based on our risk. So the riskiest thing we can do will be to put user funds at risk. And so when it comes to doing something like that, basically building a new vault or a new vault system or a new set of strategies, that's where we're going to go to an audit, and we're not going to settle for anything less than that. And so we're going to start with a formal audit, and then we can use other methods such as peer review, contest, security contests, bug bounties, etc. And then when it comes to smaller scale changes, let's say changing a strategy to harvest CVX instead of BCVX or locking BCVX against CVX, which would be literally true line change, true lines of code, then we would be writing tests and having peer reviews. And when it comes to something in the middle, such as testing a new strategy, an example being the Badger vested escrow CVX, BV CVX, we will do a security contest, which we actually ended up doing in partnership with Convex Finance for testing both the locker, the contract that we were going to be using, that Convex built, as well as the strategy that would use the locker in order to mint BV CVX. So in general, our security precautions when it comes to smart contracts are the idea of crawling, walking, and then running. And every time we launch a vault, we're going to also follow that same idea by having a guest list and then slowly raising caps and then eventually unlocking them. There's also an internal talk about raising the Immunify bounty for bug bounties in order to prevent smart contract acts. I'm not sure if I'm not sure of when that will happen, but I can say that that's in the talks. So ultimately, we really invest heavily in security. Every new member of the Solidity team has to have that aspects about them, or they are just not contributing enough, and they're not going to be allowed in core. And I'd say we're moving toward a vision where we have a little, we're not going to call it auditing firm, but we have a little peer review firm inside of Badger so that every decision can be done autonomously inside of the DAO. And then every time we're doing something that is a little outside of our comfort zone, we have a partnership and we literally run basically an audit every month or two with new code in order to ensure that the code is safe and user funds are not at risk.
Got it. And I wanted to ask you about this. So I was reading the other day about an exploit, or it was an exploit that was caught before it happened and prevented by tools that are monitoring the blockchain for contracts that are deployed, like using Tornado Cash or other things that are kind of like red flags for that happen before exploits. So, do you have any comment or thoughts on these sort of like proactive tools that can see exploits? Like even if you know, like I guess an audit is kind of like people look at it and think of exploits that have happened or could happen based on their knowledge of the past and the language involved and everything. But like this is almost more like detection of attack things that commonly happen before attacks, but without having to know kind of like what the exact bug is in the code that they're attacking. Like, do you see a future where that becomes a bigger piece of the security review process?
Yeah, I would say that this can get into more of a speculative talk, and I'd love to riff-raff about it, and perhaps we could try and invite people from the Flashbots team to further the discussion. But ultimately, there is not that big of a difference between MEV and an exploit. I'm not sure if you saw some recent exploits, one of them being index.finance. I think one of them was visor.finance. If I'm not mistaken, I'm not going to name the protocol, but there was a protocol that I believe said that an exploit was actually just an arbitrage. And that's because the difference between an arbitrage and an exploit is just who is the sucker, basically. Who holds the bag? Who's the bag holder? And if your smart contract system is the bag holder, that's an exploit because your vault system, which is supposed to earn yield, is actually having a negative yield. So that's how we separate between an exploit and an arbitrage most of the times. And so but if you start to look at it that way, then the natural consequence is that the people that are currently arbitraging on the blockchain, and most of them are on the Flashbot Discord, those people are actually the few people on Earth that could actually solve this problem of detecting an attack as it happening. And so this is something that I'm probably not even the first one to theorize, but I believe one day we'll have a smart contract systems that some sort of flashbot mempool watcher will watch the mempool for a transaction that is being signed. So it's gonna happen, but it's not yet being added to the block. So it's not yet a real transaction. It's just a transaction that is about to be mined. And somebody through a tool such as Flashbots will basically take the same transaction and use it to rescue funds. And so arguably this is something that can be done today. However, to solve this specific issue, you would have to solve for generalizable arbitrage, which is the holy grail of Flashbots. And at this time has not been solved because if you could solve for front running an exploit, that means that you can solve for front running every single profitable operation on the blockchain, which will mean that the level of sophistication of arbitrageurs will basically go up by an entire level. It means that every time you're leaving, 1 cent on the table, somebody's actually already taking that 1 cent. And so I know there are incredible economic incentives for this to be solved. At the same time, there are incredible economic incentives not to share the solution. But I bet there are people working on this. And the good side of this solution is that one day we will do some sort of bug bounty on chain. We will have some sort of contract called the Badger Bug Bounty. We'll put, let's say, $1 million in the contract. And if you're able to provide some sort of call data that is an exploit, and you send us back the funds and you rescue them, we will give you the bounty paid instantly as you basically save the funds. So I can see that happening fairly recently, fairly soon. However, the problem that needs to be solved is a very sophisticated problem of generalized arbitrage.
That's interesting. So we could end up with like a Google auction bug bounty. So if I prove to you that I've created a arbitrage for $10 million, then you can bid $10,001 and pay me off. But then doesn't that take all of the pie for the exploiter? Like it's kind of like the same economic outcome.
That's the incredible part, I guess. Let's continue going through that. So if you check some of the latest Flashbots talk, you can see that miner revenue is going up while Flashbots researcher is going down. And that's just the fact of competition. Some accounts you can follow will be Robert Miller at Flashbots. I hope I think it's Robert at Flashbots. And then you would have MEV Alpha, who's a known researcher. I bet there's a million more at this time. But ultimately, what these people are doing is they are writing smart contracts that are extremely gas optimized to be able to run arbitrages where the margin is as slim as they can get away with. And they need to compete one against each other in order to get their transaction to be mined. And so what you can imagine when the miner is the single entity that decides which transaction happens and which one fails, the only incentive for the miner is pure profit, right? It's maximize profit. And anytime we talk about maximizing a list of operations, you want to think of a mathematic tool called the simplex method, which is just a way to figure out how to make the most profit. And so you would have to assume that a miner who has no personal connection to this researcher, they have no interest in the researcher. The only goal is to maximize profit. And so what that set of incentives drives is a race to the bottom, where the researcher, who's again trying to be as sophisticated as possible, as gas efficient as possible, as profitable as possible, will simply have to squeeze their own profit out in order to give it to the miner, just to guarantee that there is any profit. And so if you imagine this scenario, which is a real scenario that is happening right now for arbitrage, and you use it to save funds in the terms of exploits, then you would actually imagine that there could be a race to the bottom for the exploit side, for malicious actors trying to minimize the amount of money they have to give away to the miner in order to be mined. And then there will also be a race to the bottom on the flashbots, the rescuers, who are trying to save the funds, and they basically would have to decide how big of a cut the miner gets. So I would say ultimately, reputational risk on the miner end, because miners are mostly doxed, plus profit ratio, so how much the miner actually ends up getting, may determine in this hypothetical scenario who ends up winning. And so I'm guessing that the good guy wins because the miner doesn't want to basically get banned from doing anything and become a cyber criminal. And then at the same time, if there's a race to the bottom from the researchers, then the miner ends up getting 90% of the bug bounty while doing 0% of the work. The only work they did is mine the block. And so in this hypothetical scenario, I think the good guys win at the detriment of the researcher and at the pure benefits of the miners.
So I guess the moral of the story is I need to increase my allocation to ETH staking so I can get those. Yeah, well, and then the stakers are going to get that once there's the merge, right?
Yeah, you're right. In the case of the merge and the beacon chain, the stakers would actually be the biggest winner. And so this sounds, we're going from one hypothetical scenario to an even more hypothetical scenario, but it actually sounds like with the right incentive and the right percentage and enough elbow grease on the researcher side, everybody wins. The researcher gets their cut, they get paid instantly the bug bounty, the protocol saves the funds and saves the initial deposits, and the validators get a good cut out of it for being, for acting for the good guy. So everybody wins.
All right. Well, we've gone from security nitty gritty details to leaving everyone with a little bit of alpha as we wrap up here. So I don't know, unless there's anything else you think we haven't covered, why don't we end it there? And I think finally, as part of our commitment to security, top to bottom, we've been putting out videos on how individual users can stay safe, not just in Badger, but in all DeFi apps. So check out our YouTube channel for that. And we will be continuing to put out more educational stuff for institutional, for users, and for other developers. So stay tuned to all of the Badger channels for that. And Mitch, Alex, thanks for joining me today.
Thanks for having me.
Thank you for having me as well. I'd like to add one closing statement, which is that if we are moving toward decentralization, and again, we're basically taking an act of self-responsibility, ultimately that comes with freedom and liberty, but it also comes with the fact that you do have to take your own decisions. So in that end, the closing statement is don't trust, verify. Just make sure you can understand what you're doing and that you can prove that what you're doing is what you think you're doing, because that's ultimately you are your own safeguard and you're the only person that can really protect yourself from anything else external.
Amen. All right, guys, thanks. Happy Friday to everyone, and we will be back with you soon.